The topic which we are dealing today is about input output streams and serialization. Now, input output streams. So, Java as a language, we have file systems everywhere around, right? Because there is a file system. You can have employee files. Individual employees can have different files, or there are files where we actually have a lot of log data. So you need to design a product, and I think some of you have worked on a QA before, quality analysis, and I think that essentially also involves, and some of you also have worked on production support environments. So that also involves monitoring logs, and those monitoring logs sometimes is because of those monitoring logs is sometimes because of like is done using some products such as Splunk. And if you see in the backend like Splunk, it uses, obviously it has many features, but one feature out of it which is very important is that there are log files, .log files on the server, which this program is trying to access, the Splunk program. So it must be having it must be having programs in sorry I mean the way inside to actually go and read these files. And maybe, in certain scenarios it can also write to a different file, obviously not in the same file because it is a production environment file, but I think you get the gist of the idea from there. So, and you have multiple files. You have a video file which you have out here, like, so say if you have YouTube. So YouTube is storing files on its server, and as and when you request for it, it shows the appropriate video on the via streaming. Now that whatever information is being shown, whatever video is being shown, that is sort of streaming, and it actually will be involving the reading of the file, maybe like sending it back to the browser. And then if you run the video, then there will be multiple calls to the server to get more information. So that must be fetching the video file again and again. So file is something which is not directly from Java side. It is more of the concept which is there from the operating system side. So whether you have worked in past using Linux, whether you have Mac, or whether you are trying to work using Windows machine, you all must be aware of the concept of files. So as mentioned in the first item here, file is a way to store data. It can contain data in a format that is understood with a computer, which is in the form of bytes, or the one which is in human readable format. So it was a character format, which is Unicode character. Okay, and to represent this file, Java has created a class, and that is java.io.file. So all the classes which are related to IO stream in Java, they're in java.io. Okay, and for simplicity, let's leave it here. I just want to give you an additional information, and that part is already covered down below in the question section. But there is another package, java.nio. Okay, and that package also contains some of the different IO stream files, and they were introduced I think after Java 1.5, and they have some additional functionality. So as part of that this exercise, I have some questions regarding that, and you have to find some information for me. So I just wanted to give a heads up so that you are aware. Now, if you see this picture above, it clearly represents what exactly is a stream. Now, the first one shows, there is a program which is trying to write to a file, a destination file. And the second one, there is a program which is trying to read from the source file. Okay, and the data is not read at once. Okay, it's not that you can read the entire file in one go and there is nothing out there afterwards. So data is always read in some sort of stream. When I say some sort of stream, it is like, say, when you're trying to read data, you can't read, or maybe you can, but you need a buffer to read the data, right? So you read either one by one, like one byte, or maybe one character at a time. Okay, so if that work happens non-stop until end of file is reached, then again if you see there is a kind of stream flowing, right? The first the first character will come, the second will come, the third will come, the fourth will come, and so on. And similarly we have for the second one. So I mean, whenever you're trying to write as well, it's the same stuff. And in some cases, Java gives you the benefit, and it might be available in other languages as well. But Java gives you the benefit that you can read in buffers, maybe not one character at a time, maybe not one byte at a time, but it's a set of bytes, or set of characters. So you can read, like, say, 50 characters at a time, which is covered by the program. So the program itself gives you an option of doing that. Java has already come up with some files related to that, and you can use it. Okay. Uh, okay. So let's move forward. Now, here I have tried to create a file. Okay, and just trying to insert it. Now if you see the example here, what I'm trying to do is that file is equal to new file, and then I'm giving the location. So in my D drive, it's trying to give a location of test file.txt. Okay, now just having this particular line, file is equal to new file, and then you give the absolute path of the file, of the place where you want to create it. This line in itself is not going to create any file for you, right? This just represents it. So to actually create this file, I mean, there is another method in this particular class file, which you need to call, say, file.create new file, if file doesn't exist. All right. So this gives you, just in case you want to create a blank file, so you can check. So this file object will be having some methods. One is exists. So if file doesn't exist, all right, then in that case you go ahead and create a new file. Or in other words, as soon as you add some, or another way, as soon as you add something to this particular file, it's already created. The test file is already created. So this is a second way where you need not like explicitly go ahead and create a file. So I have followed the second way, where I have taken a file output stream, all right, and then the data to be inserted, which is first data to be represented, and then output stream dot write, and data to be inserted dot get bytes, all right, because this is string, and Java gives you this get bytes API, a method within string, which can help you to convert this data into bytes. And why the data was required in the form of bytes, that we'll discuss. Now after that, you have to close this output.stream. So once you are done, if you execute this program in your local and you go to your workspace, sorry, to your file system, you'll see that in the D drive, this test file.txt has been created. All right. So that's how it is. Now the thing which has to be noticed here is, I mean, this class we have already discussed, as I had mentioned here, that the file on the file system is represented by java.io.file class. Okay, but what about this file output stream? All right, and the second question is, why do we need the data to be in bytes? So the thing is, if you see here, I had given a hint beforehand as well, that file can contain data in two formats. So in Java as well, you have two streams. Okay, so what is stream is being shown here? The stream, they can be of two types. One type is byte stream. The second type is character stream. So this represents a type of stream. This represents a type of stream. All right. Now the thing is that if you want data in the form of bytes, whether you want to write in the form of bytes or whether you want to retrieve in the form of bytes, okay, in that case you have to use file input stream and file output stream. So file output stream is for output purposes, in the sense that you want to write somewhere. File input stream is for input purposes, you want to read from somewhere. Since here we wanted to write in the test file.txt, we have created an instance of file output stream, and then we have some data, all right. And since it is this particular class file output stream will only work with bytes, this output stream.write is trying to write data over it in the form of bytes by calling .getBytes method, okay, and then closing it. So the point to be taken from here is, uh, input output stream actually represents a data, okay, file represents the actual file on the operating system. Java has two types of streams, byte stream and character stream, okay, and you can insert data or read data from the file using either of these streams. The classes are different, okay. For byte stream, the classes are file input stream and file output stream. All right, now let's move ahead. So that's what I've mentioned here. if you notice, we've used file output stream class here. As pointed out earlier, there are two types of streams, byte stream and character stream. An example, we use byte stream. For character, JDK has provided with some other classes. Alright, and there you need not call this .get bytes API. This call was necessary just because we are using file output stream. Okay. Now the classes which Java has provided is file reader and file writer. Alright. So file reader and file writer. So we don't need to convert data to bytes for doing this. Now let's see an example. So what I've done is that whatever test file we had created before, test file.txt. Okay. Now that text file.txt, I'm trying to read data from it. So what data it already has? The data which it already has is first reader to be represented. And now when you have a reader which reads this particular file, alright, so what do? You do reader.read a, and then you print all the data, and when you will print it, you'll see the same data to get printed on your logs, first data to be represented. Okay. Now we have like you can ask that we have this character a as new char 50 here, right? Why is that necessary? So this brings us back that, see, the file reader deals with character streams, and Java as such, it gives you certain features. So it gives you feature that, it has methods to either you can read 1 byte at a time. Okay, so every time you do a read where you don't have to pass the character array, just it is reader dot read and then open braces, close braces, semicolon. So whenever you make this particular call, we are able to read one character at a time, and that's how it is. And you can keep on printing it, or maybe writing it somewhere, or maybe work on it, but that's how the details are there. Okay. Now once you have that, you can iterate over it. But what I have done here is that this reader also gives an opportunity that instead of reading byte by byte, once it defines a buffer of 50 characters, and once you are able to read those many items, it will only read 50 items, 50 characters, and once that is done, you can go through it. Okay. So what has been done here is reader.read a. So it means that whichever file the reader had reference to, and in this case it is test file.txt. So whichever file reader had reference to, you will read from there how many characters? 50 characters, and store that in the array a. Okay. And then later, if you see, we are using the enhanced for loop to loop over the character array, and then print each character one by one. And once that is done, we close the reader object. We close the stream. Alright, the stream has to be closed. So once you do this, the 50 characters will come up, and if you say this, the number of bytes the number of characters which we have because of this line, it's not much. It's 4, 8, 10, 12, and something more, but it's not really 50. So you are able to see the entire file in your console. So that's how it works. Alright. Now coming to classification of IO streams. So input output stream can be classified in various ways. Okay. So you have, if you see, there are two streams. One is output stream, okay, and that deals with writing data in the files, and then you have input stream, which deals with reading data from the file. Now once you have that, we have, just a second. So once you have that, there are various classes out here. You have input stream, and input stream is just an interface, and output stream is also an interface. So input stream is implemented by, if you see, file input stream, which we already discussed. That is the second one out here. Then you have other stuff as well, like say filter input stream, string buffer input stream, sequence input stream, byte array input stream. Now if you go into the implementation for each one of them, they are just a way to help you better. And when I say that, it's not that there is a lot of difference, in the sense that the work which can be done by one of them uh, can't be done by the other one. I mean, you can use the other one as well to do it, and it is just a way of you're saying it reduces some of your effort, so it's there for your benefit. So it's not that you can't live without those classes. All right. So you have byte array input stream. So byte array input stream means that you can read an array of bytes at a time. File input stream we have already discussed. Similarly, you have filter input stream. You have string buffers. You're able to read a buffer of strings. Then you have sequence input stream, which has some different functionality. So it goes on like this. So in fact, what I mentioned here, I mean, there are a few more details. I mean, there are a few more classes which are out there, and it depends. I mean, if you decide to add on to something, you can take up new classes as well. So if you see here, we have this input stream, and then the which is the next important is filter input stream, and we'll come to it. Now let's come to the output stream. So in the output stream we have various classifications. The second one, the file output stream, that we have already dealt with, right? And then you have byte array output stream, which is similar to byte array input stream. And byte array output stream, you are able to write an array of bytes at a time, not a single byte at a time, but an array of bytes. All right. And then your filter output stream. So what is the significance of filter output stream? So the filter output stream, as the name suggests, I mean, it's very much clear from the names. And again, this is one of the programming tips from my end, that whenever you're trying to write classes or maybe methods, remember one thing, that classes represent nouns, all right, and methods represent verbs. So whenever you're trying to write a class, make sure that whatever name you give it to it, it's a work which it does. It's clear from the name that like what is the exact functionality it encapsulates, and then give it a noun name, not a verb name. And the methods which are there inside that particular class should be having the verb name. So that's how the naming nomenclature rules are. I mean, it's not that if you don't create it in this way, there's going to be some problem, but this is a normal way that it's followed. Okay. Now coming back to the core discussion. So what about filter output stream? So filter output stream and filter input stream, they are the name itself suggests what it stands for. So it's basically like you get some data, all right, and then you work upon it. Okay. Then you see what needs to be done. Okay, you enhance upon that data, you filter some data, and ultimately pass that data onto the actual implementation, all right, and that actually works on it. Okay. So this essentially means that filter input stream or filter output stream won't be able to work independently. Okay. Now, if you see here, what I've noticed is file input stream, file output stream, they are used to filter the input or the output on the basis of specific conditions, thus passing a subset of data to the class which finally works on this data. So one of the examples, I mean one of the types of filter output stream or filter input stream was buffered input stream. Now again, if you see, the name is so intuitive that you can still know what it means. Alright. So let's see an example of this. So this is my buffered input stream. Now if you see here, what we're doing here is we're creating input stream. Alright. And then with input stream we're putting a buffered input stream around it. Okay. So the architecture is like this. Okay, so the architecture is like this. So you have a file, all right, and that file you're trying to read data from it, and that data which you're trying to read is via stream, right? And using say file input stream. Here we're trying using file input stream, and what is the stream of data you get from the file input stream? That is being fed into a buffered input stream. Okay, so that's how it seems like, right? So you have buffered input stream, and then you're trying to read from this buffer. All right. Now, if you see what it does is, let's say if a file has this data to be represented. Okay, fine. And this is just a random string, so don't get bogged down by what is out there and I'm missing some space here or whatever. This is just file. This is some data. Okay. Now once you have this data, there is a file input stream which you're trying to open up. So there is a stream which you have to open and which you have to close. and that's a common thing which you must be seeing in all the programs. All right. So if this is the data which is in the file, and you want to say read, uh, I mean, say entire line. I mean, this is not the only line, but it's going on till here. So you have a lot of data from, I mean, entire set of file. Maybe say 10,000 characters or 20,000 characters, and that much is not supported obviously by file input stream. I mean, that many buffers. So Java has given you a particular class, buffered input stream. What it does is that it actually goes and whatever data you're trying to read, even if you're trying to read, say, from here, this class is reading 100 characters, and you have set a buffered input stream to read, say, by default it has some setting, but you can set it to read more number of characters, and once it reaches that buffer limit, okay, like say it reaches till here, this much data will be passed on to the program. Okay, so it's not that only once this much is read, your control will go back to program, you will read it, then you'll come back and try to read it again. So it actually buffers the data for you, okay, and then you start working on it. So this means that your program has enough to work upon with that buffered data, all right, and your work doesn't stop. So it's not that your program is waiting for input like one by one. So you're reading one byte at a time and then coming and working upon it. Because network operations are intensive. I mean, it takes time, and because in today's seamless world where you have so much, you don't have so much of memory constraints. It's not an issue, but I mean, some of us have worked upon the time, and I mean, our standard was having a 500 plus MB size RAM, and then there it was difficult. Okay, so this is how it works. So with this, one of the classes, one of the actual implementations is filter input stream is buffered input stream. One of the implementations of filter output stream is buffered output stream. So which basically what it does is that it tries to work upon the buffered data which we have. Okay, so it tries to buffer the data for you before you are able to get the data. Similarly, you have other streams as well. Okay, now if you notice one thing, we have a file, okay, and then we have an input stream around that file, right, and then we have buffered input stream around this file. Now I mean, we will deal with some of the design patterns later, but I just wanted to give you a hint of the things which goes through and maybe a taste of the data. So if you see this input stream and this encapsulation which happens, that for some data is out here, then you buffered input stream works on it. Now this feature or this pattern, this is a sort of a design pattern, and the design pattern is decorator. All right. So design pattern which is being followed here is decorator. So what again? I mean, if you see the name etc. is going to be very intuitive. I mean, use whatever file input stream is out there, you decorate that class. Means you add additional functionality over it, okay, and then use it. So that's what buffered input stream is doing. It's not that it's going to do some extra like high level algorithm work for you. It's just a decorator which surrounds the data which file input stream already has. It just buffers it. I mean, it just waits for some data to come together, all right, and then gives you back the data. Okay, this pattern is called as decorator, where you add some additional features on the objects via mini classes. So here we only had buffered input stream. Say tomorrow you want to add another wrapper around it, say di input stream, and this is just I'm throwing it out here. There is no class as such. Then there is another level of decorator which we have. This is again like you have one data for and you have one stream, file input stream, and then you are using various classes to enhance that data, and this particular design pattern is known as decorator design pattern. All right, now coming back here, let's see this particular example which you have. So if you see this example, we are having one file in the C drive, all right, and we are in starting a stream, opening a stream with input stream object creation, and here we are using the byte stream. So if you see file input stream is there, all right, and then you have a buffered input stream around it, and then you're checking. So bis.available is checking on the number of whether you have anything else to read from the stream or not, and if it is there, the value will be greater than 0, okay, and then you go back and you read that particular character. So once you read it, you can print it, and then it gets over. All right, and then you have finally block where if the input stream is not null and it's still open, you can go ahead and close it. And same thing with BIS, which is buffered input stream. So both the streams you can go ahead and close. All right, and this closing is important because see here you only have one file, but in real world scenario maybe if you have employee files, there must be one file per employee, right? And I'm just considering an example because tomorrow you can come up and say that it's not valid. We might not have a file per employee. We will store all the data in the database. I don't need files, right? But at the end of the day, I mean, even if you see databases, the all the RDBMS or anything else, at the end of the day, they are just files and they are storing somewhere in your file system, right? So they must be opening multiple files and storing them. And this input stream, I mean, it doesn't belong to anyone, right? There is a file, there is a particular file in the file system, and using file input stream, we're trying to read the data from it. Okay, so whether it's file input stream, whether it's file output stream, it doesn't matter, right? And then I mean if you don't I mean if you just put it as null, if you don't close it and try to use it for some other cases, then what will happen is that some of the data, if it's not right, it will be here and there will be cross like mismatch of the data flow, and details from one file will go into the other file. So for proper work, so to release all the network connections etc which we are holding, well, at the end of the day, your program has to connect to the operating system. It has to access a file system. So all that work is already being done. So just to stop that work, for to initiate garbage collection, we just have to like close the stream, etc., which we already have. So that's what we are doing here. Input stream dot close, bis.close. So once you do this, the data will come and it is a bit faster. So maybe because the data is getting buffered, you don't have to actually wait. You don't have to actually do one byte at a time reading. So you will get a set of data to work upon, and yeah, and that's how it is. All right. So uh, this is what work which buffered input stream or buffered output stream does. Now the other thing which I wanted you to notice was this catch block exception E. Now whenever I have a class and I have scenarios like this, uh, what you can do is that you can try to write these programs by yourself. Just try to replicate in your local. Just write it down again, and try to see what like which is what are the other stuff which is out there. So you can just do a bis dot, and Eclipse will give you multiple options which are there for this method, and go through each one of them. See okay what it does, what the next one does. So in this way you become familiar with various other aspects of coding which is out there. All right. So with this exception, the point which I wanted to touch was a sort of a recap, saying that if you remember, we were discussing about checked exceptions and unchecked exceptions at the earlier point, right? And but checked exception was that you as a programmer are accessing say some JDK library, some Java class which is already written by JDK, or maybe you have written some methods in your class, say employee class. Now you are trying to write some methods, say get salary details, and in certain scenarios, like say if number of days in worked in the month is zero, from that particular method, you just want to throw an exception. In that case, you do throws exception. This is a declaration which has to be there in the method to signify that this particular method throws the exception, right? And then maybe you can define your own custom exception, or can throw one of the exceptions which Java already has. So in this case, this input stream, this buffered input stream, they all throw the exception IO exception. So it's a type of an exception. So since it is a checked exception, it is being thrown by file input stream and buffered input stream. From here, you are going to get an exception unless you make a specific provision to handle it. So as discussed earlier in one of the earlier classes, checked exception, if it is being thrown from some place, checked exception ensures that in a program you have some sort of handling for that for that exception. Here we are catching it, right? So there are two ways to handle such kind of exceptions. One is either you catch it up, okay, which is like let's deal with it, or throw further. So here we are catching it. If you notice the examples above, we are trying to throw that. So here throws IO exception is out there. All right. So that's how it works. Here if you say again throws IO exception. So here we are trying to throw it. If you are not like throwing the exception further, you have to put it inside try catch block. Okay. Now let's come below. So here this in turn gives you most of the information and about streams, and just play with it. Try to write few classes, try to access some files which is there on your local file system, and try writing about it. Okay. And one of the work which you can do as an exercise is that you can go and try to write classes for all these individual streams, when input stream, output stream, and if you get stuck somewhere, try to Google and try to find what they stand for, how to code it further, what extra information they give. In that way, you will gain much more information. All right. So I mean, I really wanted to do that. So the other topic which we had to cover apart from input output streams is serialization. Now, what exactly is serialization? Now, see if you see the word, it stands for like it stands for serializing something. It's put in the serial format, right? Now, what does serializing mean? Serializing means, like, say if you have number of attributes inside, say, a class such as car, right? So your class car, and the attributes are like, say, color. Attributes are type of tires. Okay, attributes are whether you have is Bluetooth connectivity. Okay, so there are a number of attributes like this. All right, and then when you there are a number of attributes. So when you want to write this data into file, you will have to serialize the data, like say write one by one. Okay, and that is what this serialization in Java does. So you write the data one by one in this way for all the objects in a particular file. All right, and then read it somewhere sometime later. Okay, so basically serialization is used to write object to a file on the file system so that the state can be transferred to a remote location or the details can be retrieved later. Now what this essentially means is that uh, say if you're writing some kind of program where you need to do remote connectivity, so if you would have so you need to do some remote connectivity. So in that case, you'll do some level of socket programming. So everywhere where you do some remote connectivity, like say I connect to Raghav's machine or I connect to Reena's machine. So in that case, I need to know their port numbers, which like where I can access the data from. I need to know the host names, maybe the IP address, and then I have to do socket programming to connect to their PC and then get some data out of it. Now, doing that, say if they are hosting employee object as such, and they are the ones who are supposed to work on the employee details, and one of the methods is say get salary. So if you have get salary API and it's out there, and you need to pass employee details, so you need to pass everything which a car or say employee has. I'm just giving an example here. So all these attributes have to be sent over. So how will you send it to a remote system? You have to send this data, right? I mean, object, if you see, is only a representation. It only has existence on the JVM where it's running. But outside JVM, I mean, if you go to a C++ program, or you just have this object, I mean, out there, it doesn't hold any meaning. I mean, to an operating system world or to a computer program, I mean, it doesn't mean a thing, right? Because it only has reference, it only has existence with respect to a JVM. So, how to let the remote system know? How to let the remote system understand that this is the object? Okay. So one way is that you have primitives, have all this data, but that is going to make this entire structure very cumbersome. The other way is I put all this object data one by one in a file, okay, and send it over to them to look into it. This can be done because file as such, whatever you understood, we have dealt with files here, right? File stream, file and file streams also we have dealt with. So we have this kind of data. So we can I mean, to do this, like we have to write the object, we have to understand that how to write the attributes, etc., what is the name of the class, how to retrieve or restore that state. So that we can do when using serialization. So serialization gives you the opportunity to actually save the data of the object in a file. So actually, like I showed here, right, that you have test file.txt, or maybe here you have test.txt. Similarly, you have test.dat, or maybe something on that sort, and that particular file contains the attributes, the actual attributes which has to be stored for that particular object. Now, this is serialization. Deserialization is reading the data from this employee.dat or car.dat which we have created before. So this is deserialization. So this is important with respect to various things. One of the things which we discussed earlier was about the remote location. Other things is like, say, and think about various practical scenarios. So one practical scenario is you have restarted the server, and because of some particular scenario, I mean, your system is shutting down. And while it's shutting down gracefully, it's trying to see what all data is out there and just storing it in itself so it can be used later. And it is a concept which you will have also implementation in your .NET world. You also find the usage in the in other languages. So, just for reference, if you see, say, XLS or Word, and it crashes without giving you much notice, if you open it again, you will see on the left hand side the option where you just go and select the files which were open before it actually get closed, and there's an option to recover it. How do you have that recovery possible? That is because somewhere on your file system, while it was crashing, it was storing the state. Okay, and one of the ways, and I mean, I'm no Microsoft expert, but one of the ways to do that is serialization. You serialize the data uh, onto your file for a particular object and then retrieve it later. So that's what I meant when I said that the state can be transferred to a remote location, that the data which an object has can be transferred to a remote location, or you can retrieve the details later. Okay, and to achieve this, Java has an interface serialization. All right, and it by itself it provides Java itself provides you the implementation for serialization interface. All right, and to write object to the file, you need to use object input stream, and to read data from the file, you need to use object output stream. So these two streams are already defined, I mean, by Java itself, and you can use it. So if you see here, like, say, what we are trying to do is that we are again trying to have a file output stream, and then we are again trying to having a decorator pattern here using object output stream around the file output stream. And then in the next line, I'm trying to create the instance of car object, and then you set the attributes as Bluetooth connectivity there or not there, and blah blah blah, and then doing out.write object my Toyota. So this is doing is this is writing the actual details of the file, and the basic implementation of serialization interface which Java has is that all the attributes which are there in this particular class, like, say, here what I was saying, we as defining attributes such as color, type of tires, is Bluetooth connectivity. So these are the items which were out there according to me. So these attributes will be written in a file. So do an exercise for me, please. I mean, to understand all these things better, however hard I try to, unless you try to write it down in your local machines, and it's not going to get clear. So just try to write everything up, try to play around with it, and that is going to give you much more information, right? So if you like have this my Twitter object, and you set the attributes which I've defined in the WordPad out there, and do out.write object. After that, open up the mycars.dat file in your local file system and try to look what it is. You will see that it contains all that data using a semicolon or anything else. So there are markers of the object starting as well. And this is because you can store a list of objects also, right? So if you store a list of objects, the same object will get repeated number of times, right? So it has to have some way of discussing one object from the other, because I mean, this serialization is also valid in case of uh, in case of uh, yeah. So I mean, serialization also valid uh, for other cases as well. I just forgot what I was trying to speak, but anyways, now you have object input stream. So if you see object input stream as well, we have the stream, and that is around the file input stream, and we are trying to read the object this time. So now, see, the beauty is in one place. I mean, right now if you execute the program in morning, whatever program, the state can be saved for that particular object in .dat, and then I go to office, right, or I go to some other place, and then I do my work, come back, and then again start working on it. But again, I have to execute the program till that level. But I can have something where I can just go ahead and you retrieve this object of whatever I've saved in the local machine, and then start working on it. Another great example of serialization interface. All right. So this is what serialization interface is all about. The other things which has to be noticed is, like, say, not all the classes can be serialized. All right. Serialization is a sort of interface which you don't have to provide any implementation for. It just shows Java that what stands for. So like, say if you have a class, or say, called car, right? So let's go ahead and create it. So if I go ahead and create a class, let me create a package for it, com dot streams. All right. So I go ahead, going to create a class called as car. All right. Now if you create a class like this, by itself, if you try to serialize it using the streams which you have out here, Java is going to give you an option of saying this class is not serializable, because by default not all the classes are serialized. You have to let JVM know that, boss, this particular class needs serialization, so you inject your code at runtime, or whichever way you have, uh, just make it serializable. And what we do for that is we implement serialization. So there is a interface, right, which we're discussing, serialization. So if you do a sorry, that name was wrong. So if you see, this is a serializable interface. All right. Let me increase the font a bit if that helps. Okay, so try to increase the font a bit. So if you see, it's not even after you implemented the serialization, it's not asking you to do anything, right? Because it already has the by default Java has implementation for it. It doesn't ask you to add any implementation. This is sort of an interface where Java already injects the code which it has at runtime and uses it. It doesn't expect you to write serializable logic every time, but it wants you to add this implement serializable interface wherever you want those classes such as car or employee or anything else to be serialized. All right. And this just adds as a marker for Java to know that what has to be done for this particular class file. All right. So this sort of an interface where you don't have any actual implementation. It's just a marker. Okay. So this is how we do it, and let's add some attributes to it, like, say, private string name. Okay. Then you have private string say type of tires. Then you have private boolean is Bluetooth enabled. All right. So we have such things, and then you can have the getters and setters, which are also known as mutator and accessor methods. Using third option is file, edit source. Click on source, then go and generate getters and setters. You get all the options. You can do a select all. Click on OK. So this actually generates the getters and setters as well. Now, when you're trying to like when wherever in a code you're trying to run this piece, all right, to implement serialization, then in that case, all this data will be stored. So you'll have name, type of tires, is Bluetooth enabled, which is getting stored. Okay. Now, say name is something which you're not interested in. You're only interested in type of tires and is Bluetooth enabled for that car or not. Okay. And maybe it's not that important. The name is not that important, and it's very big. It can be like, say, Hyundai, Santa Fe, blah blah blah, and that information is useless for you because of whatever reason. You just want to have this. You just don't want to store this name, and this may be huge and transferring or saving it in the file, or maybe transferring it to a remote location, is going to create is going to can cause memory issues, because you need to store this data somewhere, right? So, and it's of no use, so you just want to remove it. So in that case, what to do? So Java gives you a benefit that, say, you have a keyword. So you have various keywords for other things as well, like, say, uh, the other keywords which we've did before is static keyword, final keyword, abstract keyword. So these are the keywords which are reserved for Java itself. All right. Similarly, we have another keyword which is transient. So if you mark something as transient, that is an indication uh, to the JVM that this particular attribute name should not be serialized. So if you mark the name as transient and follow the mechanism which has been discussed here, then the myToyota object which will come out, for it, the name attribute will not be set. Why? Because it was not saved in the file in the first place. So while recreating the object, I mean, it was set the default value, which will be either null or whatever you have defined as a default value. But this is so this is a way. So transient. So okay, is it clear now? Okay. Yeah, thanks for letting me know. So if we have transient here, so transient basically is an indication to JVM as to why this is required. Okay, I mean, whether that attribute is required or not, because in some cases that attribute might not be required. So the two things which we learned using this example was this implement serializable, which is sort of say marker for Java to know that such classes are serializable. Okay, and then it has to use its serializable logic to implement serialization for us. Okay, and then you have all the attributes here. One of the attributes is one of the attributes, or any more attributes as well, like, say, even the type of tires is not necessary. And just an example, in that case you can mark this one as well as transient. Okay, and the reason why like, once you mark it as transient, Java knows that such attributes can't be serialized. So this is just a indication to Java to not serialize this particular attribute. All right, so this is out there for serialization. Okay, uh, and this is what I had for this particular class. After that, I have sort of sort of questions, where first, many of them are used for, like, theoretical purposes, for helping you understand the theoretical concepts. And then you have various programs out here where I'm expecting an output of the program. So you can, I mean, guess it what's the output, and then try to run it and see as well, or can come back to me. So that's how it is. This is what we had for discussion for today. If you have any questions, you can ask them now regarding this particular class. Hello, are you able to hear me?
Yeah, no, okay.
Any questions for today? Okay, so just try to work on the assignment questions. For most of the folks till now, I have not received assignment questions. I know, because you're like learning all this thing for the first time, it can be bit daunting, but please try to go through the assignment questions, maybe with the old PDFs and recordings as well. And I mean, like one day it's not going to improve, but slowly over the time you're going to understand all the concepts, and also do actual programming using. But for that, you need to like deal with all these assignment questions as well. So please take care.